The James Webb Space Telescope has captured a single image, one so powerful it contains more than 780,000 galaxies. Each galaxy with billions of stars. Each star with the potential for worlds like ours. But here's the twist: these galaxies shouldn't even exist. Not this early. Not this fast. The universe is breaking its own rules, and what we're discovering may change our understanding of cosmic history, time itself, and even reality. Imagine a universe so vast, so mysterious, that even the most powerful telescopes of today can't fully capture its true scale. A universe where new discoveries are being made that are challenging everything we thought we knew. But what if I told you that our understanding of the universe, its origins, its age, and its vastness has just been turned upside down? This isn't science fiction. This is reality as revealed by the James Webb Space Telescope. What it's shown us so far is not just new images, it's a whole new story about our place in the cosmos. For decades, we thought we understood the universe. We thought it was vast, but mostly empty, with galaxies scattered across the cosmos. But the James Webb Space Telescope, JWST, has shattered those ideas, offering us an entirely new perspective, a perspective that is forcing astronomers to rethink everything. Before we dive into what JWST has uncovered, let's take a quick look back at where we were before. The Hubble Space Telescope gave us our first deep, detailed look into the cosmos. But as advanced as it was, it had its limits. Hubble could see only a small part of the picture. The light it captured came from galaxies far away, but the oldest galaxies were still beyond its reach. Before we dive deeper into this Planet 9 mystery, make sure you subscribe and like this video. It really motivates us to make such videos. And that's where the James Webb Telescope comes in. It operates in a different spectrum of light, the infrared. It can see the light from the most distant galaxies, those that formed just a few 100 million years after the Big Bang, a time we once thought was unreachable. But what if the universe wasn't as empty as we thought? What if, in the far reaches of space, galaxies were already forming faster than we ever imagined? The answers to those questions lie within the vast data that JWST is sending back to us. Hold on to your seats, because the discoveries we are about to talk about will challenge everything you thought you knew about the universe. Ready to dive into the unknown? Imagine this: a single image, an image so powerful that it contains over 780,000 galaxies. It's not just a picture, it's a map, a cosmic time capsule. And this isn't just any ordinary image. This is the Cosmos Web, the largest and most detailed map of the universe ever created. For the first time in history, we can see the universe in unprecedented detail. The James Webb Space Telescope spent over 250 hours observing one patch of the sky, just one tiny corner of the vast cosmos. What it uncovered was nothing short of breathtaking. A cosmic tapestry stretching back 13.5 billion years into the past, capturing galaxies in their most primitive, early stages. These aren't just blurry smudges in space. These are real, massive galaxies, each containing billions of stars. Some of these galaxies are older than anything we had ever imagined, born only a few 100 million years after the Big Bang. But here's the thing that makes this even more exciting. Many of these galaxies are forcing scientists to rethink the timeline of our universe. How could galaxies form so quickly and become so complex so soon after the Big Bang? This discovery doesn't just add to our knowledge, it rewrites the story of cosmic evolution. Galaxies that were thought to be primitive are now revealing structures and patterns that we believed wouldn't appear for billions of years. Spiral arms, supermassive black holes, and other complex structures, all at an astonishingly early age. But why were these galaxies forming so rapidly? And what does this mean for the entire history of the universe? The answers lie within the cosmos web, a treasure trove of data that is just beginning to unfold. Before we talk about these groundbreaking discoveries, let's take a step back and think about what we knew before JWST came along. For decades, the Hubble Space Telescope was our window into the cosmos. It gave us our first real look at the deep universe, but it had its limitations. Hubble could peer into the universe, but it couldn't look far enough back in time. You see, light from the oldest galaxies had traveled so long through space that it had shifted into the infrared spectrum, a type of light invisible to Hubble. But with the launch of JWST, that all changed. JWST has the ability to capture infrared light, which allows it to see through the cosmic dust that blocked Hubble's view. This is crucial because the oldest galaxies, the ones that formed just a few 100 million years after the Big Bang, emit light in the infrared. This means that JWST can look into the very earliest stages of galaxy formation. For the first time, we can observe how galaxies were born and how they began to evolve in those first few moments after the Big Bang. So, what did JWST reveal when it started observing these ancient galaxies? Well, the answers are both surprising and puzzling. Galaxies that were thought to be small and primitive were actually larger, brighter, and more structured than we ever imagined. Some even seem to have formed spiral arms, a feature we thought wouldn't appear for billions of years. This discovery raises one very big question. How could these galaxies evolve so quickly? And what does this tell us about the early universe's rapid growth? The more we dig into the data, the more unexpected answers we uncover. Now, we've covered the mystery of early galaxies, but what happens when we look even deeper, to the very edge of the universe? What if I told you that JWST has uncovered galaxies that are far too advanced for their time? Galaxies that defy everything we thought we knew about the early universe. We call this period in cosmic history the cosmic dawn. It was supposed to be a time when the universe was still in its infancy, a time when galaxies were just beginning to form. But what JWST has revealed is something far stranger. Galaxies that were thought to be small and undeveloped, young, fragile clouds of gas are instead massive, mature galaxies. These galaxies, some of which existed only 200 to 300 million years after the Big Bang, are already showing signs of mature structures. They are not just the beginnings of galaxies, they are fully formed, with stars, gas, and even signs of complex evolution. Some of these early galaxies even have spiral structures, something we believed wouldn't appear until much later in the universe's timeline. How could this be? How could these galaxies form and evolve so quickly? This is where the mystery deepens. It seems that the processes of galaxy formation were happening at a much faster rate than we expected. Stars were born faster, galaxies formed quicker, and structures that were believed to take billions of years to appear emerged in just a few 100 million years. This discovery forces us to rethink everything we knew about cosmic evolution. Could the universe have been much more active and structured than we originally thought, much earlier than we expected? As we dig deeper into this mystery, we begin to realize something profound. The universe, in its earliest moments, may have been far more complex and developed than we ever imagined. After the cosmic dawn, the universe entered one of its most energetic chapters. Astronomers call this period cosmic noon. It happened about 10 billion years ago, and it was the time when the universe was at its most active phase of star formation. During this era, galaxies were like cosmic factories, producing new stars at an unbelievable rate. Massive bursts of light, energy, and activity filled the skies. If we could have seen the universe back then, it would have looked far brighter and far more alive than it does today. The galaxies of this time were blazing with hot, Young stars, their cores bursting with activity. Some were colliding and merging, forming larger structures. Others were shaping into elegant spirals and ellipticals. This was the peak of galactic growth, the busiest moment in the life of the cosmos. But here's where JWST delivered yet another surprise. Even in this star-making frenzy, astronomers found quenched galaxies, galaxies that had already stopped forming stars. By all logic, they should have been burning the brightest, but instead, they were silent, dormant, and cold. How could these galaxies run out of fuel so quickly? What stopped them from creating stars during the most productive era of the universe? Was their fuel ripped away by black holes or blown out by violent cosmic winds? No one knows yet. And there's more. JWST also found galaxies with well-defined spiral arms, structures that should have taken billions of years to appear. But here they were, already formed, far earlier than expected. Something in our models is clearly missing. So far, JWST has shown us galaxies that formed faster and earlier than expected. But then came discoveries that pushed the limits even further, galaxies at the very edge of time itself. Astronomers have now confirmed galaxies that existed just 280 to 290 million years after the Big Bang. Let that sink in. In a universe that is 13.8 billion years old, these galaxies appeared in less than 2% of its lifetime. One of these galaxies, called GZZ14-0, existed only 290 million years after the Big Bang. Another, MMZ14, appeared even earlier, just 280 million years after the universe began. These are not faint, tiny galaxies. They're bright, massive systems, filled with stars and complex structures. But here's the real puzzle. These galaxies contain elements like carbon and nitrogen. That means stars had already lived, died, and exploded in supernovae to create those elements, all within the first few 100 million years. According to our current models, this timeline is almost impossible. Galaxies weren't supposed to exist this early, let alone be this well-developed. Yet JWST is showing us galaxy after galaxy that defies our predictions. So what does this mean? Did galaxies form much faster than we thought? Or is our very understanding of cosmic time itself incomplete? The discoveries of these early galaxies lead us straight into one of the biggest puzzles in cosmology, the question of reionization. To understand it, we need to go back to a time called the Cosmic Dark Ages. After the Big Bang, the universe was filled with a thick fog of neutral hydrogen. Light couldn't travel freely, and the cosmos was dark and opaque. Stars had not yet formed, and galaxies were only just beginning to take shape. Eventually, the first stars and galaxies ignited, flooding the universe with ultraviolet radiation. This radiation stripped electrons from hydrogen atoms, turning them into charged particles. In simple words, the fog lifted, and for the first time, light could travel freely across space. This moment is known as the epoch of reionization. Scientists long believed this process took hundreds of millions of years to begin, starting around 500 to 900 million years after the Big Bang. But JWST has revealed something astonishing, evidence that reionization may have begun much earlier. One galaxy, called GSC 11-1, is surrounded by an enormous ionized bubble, a clear sign of reionization. But here's the catch. This galaxy existed only 400 million years after the Big Bang. That means reionization was already in full swing far earlier than expected. This discovery rewrites one of the most important chapters in cosmic history. The universe wasn't slowly waking up, it may have exploded into action, becoming transparent far sooner than we thought. Every time we think we've uncovered the truth about the universe, a new discovery forces us to rethink everything. And now we are facing one of the biggest mysteries of all, the age of the universe. What if we've been wrong all this time? You see, the age of the universe has always been a cornerstone of cosmology. Most scientists agree that it's about 13.8 billion years old, based on the cosmic microwave background radiation and the expansion of space. But as JWST continues to send back its data, we are confronted with a troubling question. What if the universe is older than we thought? Here's where it gets even more interesting. There's something called the Hubble tension, a disagreement between measurements of how fast the universe is expanding. The Hubble Space Telescope measured the rate of expansion at about 73 kilometers per second per megaparsec, while other measurements suggest a slower rate of about 67 kilometers per second per megaparsec. This small difference might sound insignificant, but in cosmology, it's massive. If the universe is expanding faster than we thought, then it could be older than we originally believed. And here's the real kicker. JWST's deep field observations, including the Cosmos Web data, seem to confirm the faster expansion rate. If this faster expansion is true, then our entire cosmic timeline may be wrong. We might need to adjust the age of the universe, and that means everything from galaxy formation to the birth of supermassive black holes could have happened much sooner than we ever imagined. So, what does this all mean? Are we really seeing the universe as it truly is, or are we just starting to peel back the layers of a far older cosmos than we ever realized? If galaxies are forming too fast, if black holes are appearing too early, and if the age of the universe itself may not be what we thought, then maybe the problem isn't just in our numbers. Maybe the problem lies in our very understanding of reality. The standard model of cosmology has guided us for decades. It explains how the universe began, how galaxies formed, and how the cosmos evolved. But JWST's discoveries are pushing it to its breaking point. And when science reaches its limits, new theories begin to emerge. One radical idea is cyclic cosmology. What if our universe isn't the first, but just one in a series of endless cycles? In this model, the universe expands, ages, and then resets, beginning again with another Big Bang. Some scientists even suggest that the earliest galaxies we're seeing might be fossils from a previous universe, carried over into this one. Then there's the multiverse hypothesis. What if our universe is just one bubble in a vast cosmic foam? Each bubble could have its own laws of physics, its own galaxies, even its own timelines. And some believe that strange patterns like the cold spot in the cosmic microwave background might be scars left from collisions between our universe and others. These ideas sound like science fiction, but with JWST uncovering impossible galaxies and broken timelines, they're slowly moving from the fringe to the serious table of discussion. So, are we living in a reborn universe or just one bubble in a vast multiverse? The truth may be stranger than anything we've ever imagined. After everything we've discussed so far, faster galaxy formation, older universes, and mysteries that break our models, there's one more possibility that seems almost too wild to consider. Could the universe we see, the very reality we live in, be nothing more than a simulation? The simulation hypothesis proposes that everything we experience, the stars, the galaxies, even ourselves, might be part of an advanced computer program. Our universe could be nothing more than digital code, unfolding in a vast, sophisticated system. It's a mind-bending idea, but recent findings have made more and more scientists take it seriously. In fact, mathematical physicists like James Gates Jr. have found something startling in the equations of string theory, error-correcting codes, the same type of codes used in computers to detect and fix errors in data. These codes are embedded deep within the fundamental laws of physics, suggesting that the universe might not be as physical as we thought, but information-based, like a program running on a supercomputer. Could this explain the anomalies we've seen in space? The galaxies forming too early, the timelines that don't add up, and the mysterious forces pulling galaxies in strange directions? Maybe the universe isn't just obeying natural laws. Maybe it's struggling to keep up with the resolution of its own code. Even more strange is the relationship between consciousness and reality. In quantum mechanics, particles only choose their state when they are observed, as if the act of consciousness itself shapes the universe. If reality is information-based, then consciousness might be not just a product of the universe, but a fundamental part of it. Could we, as observers, actually be shaping the universe with our consciousness? If the universe is a simulation, then the very act of us looking at it might be the key to unlocking its deepest mysteries. So, where does all of this leave us? After everything we've learned, it seems like the universe is far more strange and complex than we ever imagined. We're standing at the edge of a discovery that might completely rewrite our understanding of reality itself. But what if the most exciting part of all these discoveries is that we haven't even scratched the surface yet? With the James Webb Space Telescope, we've entered a new era of exploration, one where every answer opens up more questions. We've uncovered galaxies forming in ways we didn't think possible, and found that the universe might be far older and more active than we ever imagined. But there's one thing we know for sure. We are only beginning to understand the true scale of the cosmos. The data coming from JWST is just the beginning, and with each new discovery, we are peeling back the layers of a mystery that's as old as time itself. So, as we look deeper into the universe, let's remember, the universe isn't just out there, waiting to be understood. It's waiting to be discovered, one astonishing revelation at a time. What we see next might just change everything again. If you enjoyed this journey to the edge of our solar system, don't forget to subscribe for more space mysteries. Hit the like button if you found it interesting, and share your thoughts or questions in the comments below. And share this video with friends who love exploring the unknown. Stay tuned, because the greatest discoveries are still ahead.